Have you ever just stood in your kitchen, looked at something totally normal and thought, why does it do that? Well, guess what? Science isn't just for fancy labs with bubbling beakers. It's actually a toolkit for solving all those little mysteries in our everyday lives. So let's dive in.
Okay, let's start with a classic. You have definitely seen this 1,000 times. You grab some salt, pour it into a glass of water, give it a stir, and poof, it's gone. It just seems to vanish into thin air. But where does it actually go? This simple question is going to be our guide today.
And right there, that's where it all begins. That simple little observation, that moment of curiosity in your own kitchen. That's the first step on a journey to a real, solid, scientific answer. It's literally the first step to thinking like a scientist.
Now, the cool part is, you don't have to just sit there and guess. For centuries, people have been using a really powerful, structured process to turn that curiosity into actual knowledge. It's a time-tested method for checking your ideas to find out what's really going on.
So what is this master plan? Well, it's got a name you've for sure heard before, the scientific method. And it's used by everyone from professional chemists in high-tech labs to, well, curious people just like us who want to figure out the world.
So what is it really? At its heart, it's just a systematic way to get to the truth. It's a step-by-step framework that makes sure your experiments and your observations actually lead to conclusions you can trust. Think of it as your personal guide to discovery.
Okay, so the scientific method is broken down into 7 key steps. And to make it super clear, we're going to use our salt mystery to see exactly how each one of them works in practice.
Let's break down the first 4. First up, you ask a question. For us, that's why does salt dissolve in water? Simple enough. Second, you do a little background research. We look into this idea called solubility. Third, you form a hypothesis. This is basically your educated guess. And fourth, you design an experiment to see if your guess holds up.
Now this part's really important. A great hypothesis isn't just a wild guess. It's a super specific, totally testable prediction. And it's almost always framed as an if-then statement. If I do this one thing, then this other thing will happen. That structure is exactly what makes it possible to test.
Okay, if you're going to run an experiment you can actually trust, here is the absolute golden rule. You can only change one thing at a time. That one thing you change is called your variable. Everything else, and I mean everything else, has to stay exactly the same.
And this right here shows you the difference perfectly. I mean, look at the left. An uncontrolled experiment is just chaos. You're changing the water temperature, the amount of salt, whether you're stirring or not. If something happens, you have no idea what caused it. But now look at the right. In a controlled experiment, if you only change the temperature, then you know for sure that any difference you see is because of that one single change. So much better.
All right, we're on the home stretch. So, step 5, you collect and analyze your data. You'd actually measure it. How long did the salt take to dissolve? Step 6, you draw a conclusion. You look at the data and ask, was my hypothesis right? And finally, step 7, you communicate your results. You tell people what you learned.
Now, you might be thinking, this is just a fun little kitchen trick. But this exact same process has a massive impact on everything, from the food we eat to huge global industries.
Seriously, imagine a food chemist who's trying to figure out the perfect temperature to dissolve sugar in your favorite soda. They are not just guessing. They are using the scientific method step by step to get a precise, repeatable, and reliable answer.
So why does any of this matter to you? Well, because those reliable conclusions that they come to, they lead to things you count on every single day. We're talking about better food recipes, factories that run more efficiently, and even safer food products for you and your entire family.
So let's bring this all the way back home, because the real magic here is that you don't need a fancy lab coat or expensive equipment. Your kitchen, your garage, your backyard, any of those can be your own personal laboratory.
Look, if you take one thing away from this today, let it be this. The scientific method isn't some secret club just for scientists. It is a tool for anyone who's curious. It's a way to think clearly and solve problems in a way that you can actually trust.
So I'll leave you with a challenge. What have you always wondered about in your own kitchen? You know, why does an apple turn brown after you slice it? Why does ice float instead of sink? Pick a question, any question. The method is yours now. Go find an answer.